Good afternoon, distinguished guests, faculty members, and dear students. Gratitude is the fairest blossom that springs from the soul. Today we gather not just to bid farewell to a remarkable personality, but to express our deepest gratitude for the seeds of wisdom you have planted in countless minds. As we celebrate Professor Weerasekara's invaluable contributions to the University of Moratuwa, it is imperative that we recognize the significance of listening to his experiences garnered over 4 decades. Devoting 40 years to the same university is a testament to more than just a professional commitment. It is a narrative of loyalty, passion, and an unwavering dedication to the pursuit of knowledge. Now it is my honor to invite Professor Chinta Jayasinghe, the head of the Department of Civil Engineering, who has been instrumental in supporting and organizing this important event, to deliver the welcome speech.
Thank you, Dr. Pasidu. Very good afternoon, everybody. Emeritus Professor Ruwan Weerasekara and Dr. Ravindri and all other emeritus professors, distinguished guests, esteemed colleagues, ladies and gentlemen. We are gathered here today to witness the retirement lecture delivered by Professor Ruwan Weerasekara. So I warmly welcome all of you who join in person and online. Professor Weerasekara completed 40 years of eminent service and celebrating his long journey at University of Moratuwa. I must say, we rank Professor Ruwan as one of the most dedicated lecturers in the department. Thank you, sir, for all your commitments, and his genuine approach for all the academic and other social work at the university are greatly appreciated. He kind of very particular about the quality of his delivery. So we must express our deepest gratitude towards that. And also, he's very well known as, a go-getter for many things. Now, I can still remember how he organized the Pirit ceremonies as the president of the Buddhist Society. And also, he chaired the exhibition committee. And he got all of us doing work. Thank you very much, sir, for all that. And also, I think he took the leading role in the Society of Structural Engineers to develop and enhance the society and the knowledge among the structural engineering community. So without further ado, I wish to invite Madam Premini to read the citation for Professor Weerasekara. Thank you so much.
Friends and colleagues, it gives me immense pleasure this afternoon to introduce Professor I.R.A. Weerasekara, better known as Professor Ruwan Weerasekara, a friend and colleague of almost 50 years. For most of us, IRA meant Irish Republican Army, who in that era was actively seeking to end British rule in Northern Ireland. Rest assured, Ruwan bears no link with that army. His initials are I for Elisha, R for Ruwan, and A for Abe Ratna. Ruwan Weerasekara, RW for short, like the other RW that we are perhaps all too familiar with, is a distinguished product of the same school, Royal College, Colombo. Ruwan spent all of his school years at Royal College, where he strictly followed the first verb of his school motto, which translated means to learn or to depart. Having secured the highest aggregate among the students from Royal College, Colombo, who sat the GCE advanced level examination in 1976, young Ruwan commenced engineering studies at the University of Moratuwa. Whether to be an engineer was his childhood ambition, I am yet to discover. Ruwan and I were among the 125 undergrads who entered what was popularly referred to as the Katubedda campus of the University of Sri Lanka in June 1977. And subsequent to our first examination, among the fortunate 50 to be selected to follow civil engineering, which at the time was the most sought after discipline. I learned only recently that he in fact obtained second place at the first year examination. Incidentally, our paths had crossed much earlier as we discovered that we had been contemporaries at the same Montessori in the early 1960s. Regrettably, I do not have any recollections of that era. On graduation, Ruwan joined the academic staff of the Department of Civil Engineering. Mr. Weerasekara served the Department of Civil Engineering diligently as an assistant lecturer and was mainly responsible for imparting the principles of construction planning. That was prior to proceeding to the University of Calgary, Canada in 1985 on a scholarship, where he earned his doctoral degree majoring in structures. Dr. Weerasekara returned to the University of Moratuwa in 1991 and served as senior lecturer in structural engineering. He obtained professional membership of the Institution of Engineers Sri Lanka in 2006. 3 years later, Dr. Weerasekara was promoted Professor in Civil Engineering, and in due time, Professor Weerasekara achieved the status of Senior Professor. He is also a member of professional institutions, both within and outside of Sri Lanka. Professor Weerasekara will be long remembered as a respected teacher who painstakingly instilled the basics of structural mechanics and analysis into the minds of budding structural engineers. While his colleagues were quick to move away from the chalk and talk method of delivery, he continued with it for good reasons too, I believe, for none has or will be able to equal his clear and legible handwriting, whether on paper or on the board. I wonder how many of you have observed him writing using his left hand. It's a definite must watch. Professor Weerasekara's research interests are in structural engineering and encompass analysis, design, and materials technology. He is the co-author of over 60 research papers. Professor Weerasekara was a member of the Building and Structural Engineering group of the department, where he contributed to the improvement of structural analysis and design modules of the undergraduate program, and also played a pioneering role in the commencement of the postgraduate course in structural engineering design. He served as its first coordinator and taught several subject modules. He also contributed to the PG course in highway engineering. Professor Ruwan, while contributing as a resource person, was also instrumental in organizing short courses by the Department of Civil Engineering under the auspices of Uni Consultancy Services of the University of Moratuwa. His service extended beyond the confines of the Department of Civil Engineering. He served as the first Director, Quality Assurance of Faculty of Engineering. It was during his tenure that a process of documentation to enhance the quality of teaching and assessment within the faculty was first introduced. Professor Weerasekara's links with industry were not restricted to providing his expertise as a research collaborator and/or consultant, but extended far beyond. His name is synonymous with the Society of Structural Engineers Sri Lanka, the apex body of structural engineering in the country. Dr. Weerasekara was a founder member of the society and served committedly on its executive committee in numerous positions for well nigh 25 years, including that of the honorary secretary for 7 years. Professor Weerasekara was elected to the coveted position of president for 4 consecutive years from 2012 to 2015. He had the privilege of leading the society during its Silver Jubilee year and chaired the International Conference in Structural Engineering Towards Excellence in Structural Engineering, an event well attended by world-reputed professionals in structural engineering. Professor Weerasekara was conferred an honorary fellowship of the Society in recognition of his services in 2017. Ruan's leadership abilities were evident even from his undergraduate days. He was our batch representative throughout the entire period of 4 to 5 years. He led the Building and Structural Division of the department for over 7 years and the Society of Structural Engineering Sri Lanka for a considerable period. It was not always plain sailing, with colleagues holding diverse viewpoints, but Ruan always firmly stands ground. It is indeed a misfortune that the Department of Civil Engineering did not benefit from his stewardship. An introduction of Ruan would be incomplete if no mention is made of the manner in which Ruan overcame setbacks in his personal life. Since the demise of his loving wife, Renuka, he has played a dual parental role to his only offspring, Ravindri. She is no stranger to many of us. She, in turn, has been very cooperative and encouraging her father in his career. I am happy that Ravindra is able to be with us in person for this felicitation ceremony today. Professor Ruan Weerasekara has had a profound impact on the department and leaves an indelible imprint in all our minds. It has indeed been a privilege to work together. His pioneering activity within the university and the wider structural engineering fraternity is noteworthy and a hard act to follow. Thank you, Ruan, for committing 40 years of your life to the betterment of the Department of Civil Engineering of the University of Moratuwa. May the Triple Gem bless you and lead you to a contented, retired life.
Now I cordially invite Professor Ruan Weerasekara to deliver his farewell lecture.
Okay, thank you, Premini, for those kind words. I think we have come a long way from nursery to present stage. So I also learned that very lately. So it's good to introduce me, and thank you very much. Now my presentation today on my retirement lecture has few parts, 4 parts. One is to deal with an introduction, and then I have some research work related to bond studies. Then we have some work related to serviceability of concrete structures, and then shear design. As an introduction to my talk, I will say a few things about myself. And concerning my education, I have to express my gratitude to three institutions. Firstly, Royal College, Colombo, where I had my entire education. University of Moratuwa, Sri Lanka, where I did my first degree and later joined staff. And then University of Calgary, Canada, where I did my postgraduate studies. So these are the three institutions I attended for my studies. My profile today is due to following individuals. Firstly, I like to thank Professor B.L. Tindakol, Professor S.R.D. Chandrakirti, and Professor Priyandas of University of Moratuwa, and two professors I came across in Calgary, Professor Robert Louvre, my supervisor, and late Professor Amin Ghali. Some people say that I am not an engineer, but a mathematician. There is some truth in that statement. In this connection, I wish to say that this is due to the memory of a few people. Firstly, I would like to mention that late Mr. Samson Vedagama, late Mr. Eran Fernando, late Mr. Chandra Rupasinghe, and then Mr. G.A. Savesinghe. If not for them, my path would have been in the direction of biology. I am proud to say that I am a 100% Royalist. I obtained best results at Royal in 1976, advanced level examination. Now here, I don't know whether you can recognize this picture. I see this one winning the award from then President William Gopal Lal. I entered the campus of University of Sri Lanka in 1977. I passed out in 1982 from University of Moratuwa, Sri Lanka. My major development projects all around the country, there was high demand for civil engineering. I obtained the first year exhibition award in 1978. The field selections were made based on three items. One is building construction, surveying, and average mark. I topped the civil list that year and selected to do civil engineering, which was in heavy demand. My colleagues are Dr. Mrs. Premini Hettiarachchi and Professor Anuraneka. I graduated in civil engineering with a passion for structural engineering and joined the civil engineering department in 1982 December. The building and structural engineering was my obvious choice. At that time, we were called assistant lecturers. If you look at this, you will see some faces whom you can recognize. We have Atua Hudayaka, Savan Bandara, myself, then Samantha Hettiarachchi, Premini Hettiarachchi, Anuraneka. Others, of course, are not here. So areas for specialization, I remember that time Professor Chandrakirti gave us the whole list, and I selected pre-stressed concrete and bridge engineering as my area of specialization for postgraduate research and courses. At this point, I must say, in 1985, I was awarded an assistantship to do MSc in structures at University of Calgary, Alberta, Canada. In this connection, I must be thankful and indebted to Dr. Chandra Weerasekara for bringing me to Calgary. And he was spending his sabbatical here at Department of Civil Engineering, so that is how I came to know him. I was also supported by 3 strong recommendations by Professor B.L. Tendagol, Professor S.R.D. Chandrakirti, and Dr. Samara Singh. Dr. Weerasekara was delighted as I delivered the needful after going to Calgary. After studying in postgraduate courses, I had a perfect GPA. With initial research with my supervisor, Professor Robert Liu, I recognized potential and interest in research outcomes. Dr. Weerasekara was delighted as I delivered and how I performed in Calgary. This was my second turning point. Then I was in the University of Calgary, and I also taught mathematics, the best subject. I was a tutor and an examiner. I wish to extend my gratitude to Moratuwa staff for inculcating my basic knowledge and the foundation in civil engineering. My turning point to academic career was due to 3 people. We as human beings have made ups and downs. Professor Tendagol and Professor Chandrakirti, who gave, together with Dr. Samara Singh, were responsible for my resurrection after some setbacks. After I returned to Moratuwa in 1991, I was entrusted to teach structural mechanics, structural analysis, and pre-stressed concrete design. I enjoyed this task as a young senior lecturer. In the early days, my focus was on teaching and less emphasis on research. But somewhere in the middle of my career, I changed my focus, and shortly after that, my research profile enhanced. In 2009, I got a merit promotion to the grade of professor. I wish to place on record my peers for acting as catalysts by encouraging me to prepare the documents. And especially I was thankful to Dr. Weerasekara, Dr. Tishan Jayasinghe, and Professor Saman Bandara. They were responsible for encouraging me to apply. I also wish to say that the moral support given by my beloved wife, Renuka, was indelible. Now that is the first part where I thought I would give a brief introduction so that some of the information I would like to share. Then the second part I am going to talk about is about some bond studies research. And you can see in this particular diagram, which is partly hidden, that there is the part dealing with pre-stress transfer, then a part dealing with shear, and the other part dealing with cracks. Now these called transfer modeling this particular part, and this one is together is called flexural bond. Now, during the early research, we found that there is a bilinear, almost bilinear curve for pre-stress transfer, covering both transfer and flexure. My MSc research was on structures. It was a combination of experimental and theoretical work. Therefore, the training in Calgary has given me a good blend of theory and practice, even though I was from academia. It was investigation of transfer and flexural bond related to pre-tension pre-stress concrete, which was a two-stage phenomena related to bond. So this slide shows the nature of what engineers and academics believe on how the profile of pre-stress transfer and flexure should be. First, I had to design a series of beams. This was not traditional beams, but was meant to be research beams, cross-section, where all identified parameters could be modeled. So first stage, we have the transfer bond stage test, and then the second stage, we have flexural bond stage. And you can see this a typical cross-section and the deep flange T-section. And this area is especially important because that is where the problems are, and we had to investigate this part. And also, we adopted a supporting system which is slightly different from the traditional. This is where we supported this beam, and we were able to model all parameters that were relevant. I tested 13 beams which were 5.7 meters long. It was a full-scale test. I had to use the load flow for casting, storing and testing, and the variables tested were concrete strength, steel tendon diameter, cover and spacing, and beam width. Now these, we had developed 6 cross-sections where base case had 3 specimens and 2 each for other cases. So these are the sections that we use, and I had to cast 13 beams. Now this was done in the load flow. Now this is not a diagram to scale, but it gives you all the details of the arrangement. We have an elevation and a plan giving us the beam that was casted, and these tendons were connected to the bulkhead, and this is the decking part, and then we were able to cast these beams. Now these are some results which we didn't have in the past. This, we originally thought it was a linear variation, but now based on this particular study, we are able to show that there is this sort of variation. Now these are experimental points, so you can see you won't get a smooth curve, but the trends are very clear. Now at this point, my supervisor said, let's develop a theoretical basis and confirm the findings. Now at this point I could remember that I did that but third year for strength of materials at Moratuwa. That is thick cylinder theory and press fit cylinders. I'm sure you could not remember this. It was our time, we had that in the curriculum, and now we have taken that off. At this point, I could, the results of the study showed that radial cracking of concrete is inevitable. Because what we considered here was like this is unstressed concrete and this is stressed composite unit and this is unstressed steel. So when you combine them, we get the composite unit. And as a result of that, there is radial cracking. So that is something we found in the first part of the study. So, based on details analysis based on mechanics, now I have avoided putting equations in this presentation because nobody likes to see those. So we were able to find that steel is surrounded by concrete, and in the first diagram you see there is no cracking. The second one, we can see it is partly cracked. Inner part is cracked, outer part is not. And the last one shows the whole section is cracked. And also, I was able to recognize, identify symmetry in the crack pattern. So I decided to use an anisotropic analysis and with radial symmetry. So once I did that, I had to find a solution. I got a very complex differential equation. Second order, second degree, non-homogeneous differential equation. So actually, even today, analytical solutions are not available for that. So I had to go for a numerical solution. So where I use Runge-Kutta method, fourth order, to solve this. So once I did that, I was able to find out what the stresses are and what the displacements are, and I was able to do something which has not been done previously. Then in each of these cases, we had this particular stress distribution. In the unstruck situation, we had a very small amount of stress. Then this is the partially cracked stage. And you can see this shows most of the pre-stress is transferred by this case, and then fully cracked stage we have this particular distribution. Now these are, one is the circumferential stress and the other one is the radial stress. At this stage my supervisor was very helpful because I had to go into material science, and where he was very helpful as he had some experience in it. It was lucky, I was lucky, and I built into the research this idea. Now I was able to handle my previous findings and explain original observations. This is where I struck gold. I thought this was original and creative. I requested for a transfer, and my supervisor agreed and gave a strong recommendation. I had to write a report instead of a thesis, concerning all my research, what I have done after coming to Calgary. At this stage, I was able to get the transfer to PhD, and the program based on my GPA and novel research achievements. I was the first to get into the PhD program directly from BSc background in the history of graduate programs and structures. This saved me from writing 2 dissertations, although I had to sacrifice my MSc. This saved me time and effort, and I was then confident of my PhD. To convert from PhD student to PhD candidate status, there is a boundless exam called candidacy. It was a 6-hour written paper and an oral exam. Believe me, facing that was most difficult than the final defense. To me, the final defense was a cakewalk. Because by then, the first question they asked was, you are the person who knows best in the world of this subject. What is your opinion on this? That type of questions. So I was delighted and to answer some of them. Now, based on the initial part, that is the transformer part, I was able to finally have an equation for transfer length. You can see this first one is transfer length is here, and you can see the 4 parameters are investigated. This is the free stress in the steel, this is the steel diameter, and this is the effective cover, and this one is the concrete strength. So it was possible to create new knowledge and was able to propose new code equations for pre-stress transfer, which was complemented by new theoretical basis. However, working with data related to power and spacing was difficult because there is something that is variable in many ways. In the longitudinal direction, we had this sort of development. You can see the first diagram shows how the Poisson's ratio effect is influencing, and the bottom part shows how the pre-stress is developed. Well, the first part is for fully cracked zone, second part is for partially cracked, and the third part is for uncracked. Now, the shape of the curve for the first part is concave up, the second part is almost linear, and then third part is concave down. Now, this has not been recognized, but you must have seen my slide I showed earlier based on experimental evidence. We had that type of curve. Then the second stage where I conduct the testing, flexural bond test, and this is the setup. Again, this is not to scale, but it shows all the parts that are relevant to the testing. Now you can see here that the arrangement I mentioned earlier, how we are supporting the beam, and then by doing that we are not compressing the tendons. So therefore that is not going to cause any effect. So this has not been done previously, so but we wanted to do this, and we had 2-point loading, and there is a spreader beam, and then 2 rollers and a fixed roller, and then we loaded this earlier stage. However, fracture bond studies require further investigations. I didn't go to create a theoretical basis because time was a factor. Also, it would be prudent to find a theoretical basis for flexural bond behavior. Another observation on transfer bond is made, large end slips. That was evidently the transfer bond stage. For flexural bond, more or less these slips were very small. So for flexural bond, more sensitive instrumentation is required. And you can see, I also constructed miniature specimens and cut them into slices, followed by polishing them with grit, and then I observed them using a microscope. And doing that, I was able to observe radial cracking. Now that is what I see here. Now this is just a part of a wire off the stand. You can see what the scale is, and you can see these are the shape of the crack. Of course, concrete is not a homogeneous material, so we have cracks like that. So you can see a lot of people were interested in that because cracking is one of the favorite topics in structural engineering. So I think that is all I wanted to say about my research, what I did initially for my thesis. In the second part, I thought I will cover serviceability of concrete structures, again where I have done considerable amount of research. Now, you can see a structure here in the background. This structure in Calgary is called Olympic Saddle Dome, ice hockey arena. And now it is used for other things as well. So it's a very useful structure. You can see the shape is in this direction. You have a curve like that. In the other direction, you have a curve like this. So it's like a saddle, right? So, you know, Calgary is a cow city. So you find them celebrating these things. So therefore we were able to see that reflected in this structure. Now the second area of my interest is serviceability of concrete structures. In particular, the effect of time-dependent properties such as creep and shrinkage of concrete and relaxation of steel effects can be determined. Now the problem here is, you can see these some examples of typical structures. One problem is concrete is a viscoelastic material. With time, it changes properties. So normally when we analyze, we use things like beam theory, then also things like principle of superposition. Now these things cannot be applied because the centroid changes, right? So that's why we were interested in this, and I'll show you in these structures we are looking at some of the material properties. You can see these creep. Priya must be quite familiar with these. And you can see there is an instantaneous strain, and then also after some time you will see there is a further increase in strain. So that is called creep. And this is something to do with relaxation and some information what we have obtained from the manufacturer. Now to analyze this, we have to use a new idea. The idea is we consider one axis of symmetry. Now this is the axis of symmetry. And on that we have a reference point. Now normally we use the centroid. Now I said we can't use a centroid here. So we just use as a reference point. And then once you do that, whatever you measure downwards is given a sign positive, and then we have sagging bending moments considered as positive. So we have to use a new idea. The key feature of this analysis is to limit for symmetrical sections with single axis of symmetry. Then the second feature was an arbitrary reference point on the axis of the symmetry of the cross section. It is now possible to realize new non-linear distributions of parameters. These variations were useful in analyzing creep, shrinkage, relaxation, and temperature, which is valid even for composite sections. Here we were able to calculate properties between two time intervals. Time-dependent effects related to concrete could be handled. Now this is again showing us the cross section. You can have different parts in the concrete. It can be homogeneous or not, it doesn't matter. And this is a strain diagram. And you can see strain can be described by giving the curvature here, and then this is the axial strain at the reference point. So earlier we didn't need that 2 points, because two things, because principle of superposition was applicable. But now here principle of superposition is not applicable, so therefore we had to use two parameters. I'll show you some possible cross sections we can analyze. And you can see this is a T section with non-pre-stressing steel here in solid, and circular one is pre-stressed. So this type of thing is non-pre-stressed steel that can be analyzed. Then here we have a precast member, precast pre-stressed member, and then made by adding a concrete slab, so that makes this composite. And again you can see here pre-stressed, non-pre-stressing steel, precast concrete, all that can be combined in this particular method. And then also in this one, it is steel, but steel can be modeled as a concrete part, and then use appropriate parameters, and then this is also a composite section. So these are some cases showing you the capability of this method and how we can employ our findings and then go from there. Now these are some of the parameters that we have defined. We have these two parts of concrete, reference point, bending moment, which the Howing moment is positive, then distance to concrete centroid, distance to pre-stressed steel, not necessarily centroid, it can be any point on concrete, and this is for non-pre-stressing steel, and so forth. And this is the strain diagram we have for initial stage at time t0, and this is after some time, the changes that take place with time. Now this is not just limited to cracked and uncracked parts, because the same procedure with a small approximation we can solve in the same fashion. And this was based on a matrix formulation but simple enough to analyze any type of structure, which does not cause twisting. In this analysis, we found the curvature to be a major role, as it is the governing criteria to determine deflections and rotations. For statically indeterminate structures, we could follow the same analysis using the same procedure and solve the problem. Now this is something else I have tried to show here. Now sometimes in structures at the serviceability stage tend to crack. Part is cracked, part is uncracked. So that we are able to analyze in more detail than the homogeneous ones. So basic calculations can be performed. The process is a bit more tedious, but the same approach can be applied. Now once we have a beam with several sections identified for calculation of the curvature, which is responsible for the deflection, we have different curves, and I have selected an example here. Once a curvature was found to have several sections, deflections could be computed using a simple numerical analysis which can be handled using a computer. In the presence of self-equilibrating systems, the same analysis can be employed irrespective of structure, whether it is determinate or indeterminate. Most of the calculations can be computerized where numerical procedures are followed. It is also possible to determine crack width or crack spacing. When one is known, the other can be calculated. Indeed, we follow matrix methods of analysis with basic matrix operations with 2 by 2 matrix inversion. Now you can see, I said when you have cracking, you can have 2 stages. Now this particular one is uncracked stage, which is in this solid line. Then the other one is crack stage. We have the second line, and the actual one is this broken line, which is giving a mean curvature, and from that we can calculate deflections. So I think it's hard to explain the versatile contribution of this research, but because it involves some kind of training, and so I thought I will limit this and then go ahead with the next topic. The next one is I'm interested in shear design, which I developed at Moratuwa with a group of students. And you can see this is the Olympic Oval at Calgary. This was the ice hockey arena, and this, you can see concrete beams here, right? They were post tension, and I thought I would show you and share with you. It's meant for mainly speed skating, right? This particular arena is used mainly for speed skating and ice hockey, and it was constructed for Olympics when it was held in Calgary, Winter Olympics. Now this is what we did here. With the shear design, we have to identify for an inclined crack, or say cylinder, a strut, how it is varying when you change the axis. So it's like change in the reinforcement axis, when you change the angle, how the shear would change. So these are some of the third topic I want to discuss a bit, which is also my novel area of interest as well. And the procedure developed at the University of Moratuwa is challenging because we have done this test and rather we have analyzed this structure, and we were able to use some of the things which are used for bond studies in a different way, and then identify, that is, the dimensions of the cylinder were based on how we identified critical depth and critical width, and depending on which is critical out of these, and based on that we could analyze. This is what we have for situations where critical depth, and this is what we have for which is there for critical width. So at this stage I thought I should show you what a crack is. Always we talk about cracks, but never looked at the inside of it. Now you can see this is a crack we know. This is, you can see light can pass through this one. But beyond this, you can see crack becomes smaller and smaller, and then becomes a micro crack. And in the process it picks up stress. Right? This means this part is very useful. We can make use of this for benefit of us, because this is called a cohesive crack, and cohesive crack is one that transmits tension across the crack. Right? So therefore it was useful. Now this is extracted from this example, and this was presented in 1983, but many people did not go beyond after that. But still we recognize this, and we were able to do our analysis based on that. Now in the process of convergence, there is three possibilities depending on the degree of radial cracking. That is whether the section is uncracked, partially cracked, or fully cracked. So that is, we have here, this is the uncracked situation. This is partially cracked. You can see it cracked up to a particular length, and here cracking is coming up to the surface. When it reaches some point here, we say it has failed. Right? So that is the criteria we adopted, and we gave a specific value here based on the stress strain curve, and that is our shear failure. Right? Now, shear is a matter, something that is not very well known to us, even though we talk about shear force very often. So people have come up with various ideas, and I think I have just shown in the next slide this. I will not touch on two procedures which are known in academic circles, namely shear friction procedure, that is this one, and forming an upper bound, and modified compression field theory, forming a lower bound that is covered by this. So in a short period I cannot explain all this, so I'm just saying these are the most useful methods that are there now in the event that we are not clear with shear behavior. With this background only, we develop our own method. Shear design has been a matter of conjecture for a long time, and it is still debatable. No procedure has come close to reality as our cohesive crack approach developed by us. Here we are looking at a cylindrical strut which is inclined. A worldwide survey of shear design tests have been acquired and compared with known boundaries. So you can see, though shear is not here, a lot of people are doing research. So we conducted a worldwide testing based on Calgary, and then we were able to collect a lot of data, and we have used those to study the effect of cohesive cracking. And now it's a matter of identifying large number of variables. If I remember correctly, there were 52 variables for the worldwide survey. And based on that, we use some statistical relationship. As you can see, this is a statistical chart. It is unsafe when it is less than 0.9, accurate when it is between these two values, and reasonable about these two. So actually this part gives us a safe condition, and here this one is unsafe. It's an underestimation, so that is unsafe. So I am presenting here the outcome is shown in the bar chart form. Some results have been tested by further experimental evidence. It's required to expand the theory. But you can see we have two sets of bar charts. One is without stirrups and this is with stirrups. You can see out of these unsafe, most unsafe category is Canadian general method. And you can see other ones are in a similar fashion. But this is the proposed method, we are here. Right? And for the cases with stirrups, we have, this one is the bar chart, and that is for unsafe category, right? That is under these conditions. There is statistical measure, what I have shown here, and that is unsafe. And this one is accurate and reasonable. The second and third categories together. And you can see proposed method is very sound. It goes like that. Almost 80% of the specimens satisfy this requirement. And for beads with stirrups also, we have proposed method is very promising. So we need to study that further because more testing is required. And this one is accurate. The underestimate category. We can see again how the various modes of practice, we have selected 7 modes of practice and then compared with them. So I think I have covered 3 areas. And that is the end of my technical part now. Now I would like to pay tribute to key people who are behind my achievements. First of all, I would like to express my gratitude to my parents, my father, Lambert Weerasekara, and my mother, Violet Weerasekara, for their love and always encouraging me to do studies and enhancements towards my professional practice. I learned integrity, responsibility, dedication, and super action from them. Then I would like to express my sincere appreciation to my departed wife, Renuka, for her untiring efforts by giving moral support, and she was undoubtedly a pillar of strength to us and for the entire family. Unfortunately, she left us at the peak of her career. So that is something we are sorry about. Her demise was a great loss, especially to my daughter when she needed most. Next, I would like to thank my loving daughter for her courage and understanding during these difficult times. We did not have just a parent-child relationship, but we were best of friends. We did not have any secrets, but maintained a strong bond. She kept me going and supported me in all endeavors. In fact, she was a special child. Thank you very much. I also like to express my sincere thanks to my colleagues in the civil engineering department for showing compassion and assistance when I needed them. Thank you. Last but not least, I'd like to thank my supervisor Robert Liu for his patience and guidance at all times. I also wish to pay tribute to the memory of late Professor Amin Ghali for polishing my structural analysis basics. With that note, I end my presentation. Now I'd like to introduce the first book I have published with my co-author, senior structural engineer Weerasekara, titled Computer Analysis of Structures, which is aimed at both senior undergraduates and graduate students. The material is based on my experience in the academia and our industrial exposure. When I invited him first, he was well motivated and his dedication and super action were impeccable throughout this time. Thank you, Weerasekara. So now I would like to make a presentation. The first one, I want to present to Professor Priyan Dias, who has been a lecturer, a colleague, and a friend. Then the second one I would like to present is, we have with us Dean, Faculty of Engineering and Technology at Select Campus, where I work now, and I would like to invite him to take this second copy. Okay, so that is my part of this felicitation lecture, and I hand over to Pasitu.
Thank you, sir, for that enlightening lecture. I'm sure it has brought so many memories for all of us, including myself, where you taught us structural analysis in semester 3. Ladies and gentlemen, before we proceed further, let us take a moment to delve into the life journey of Professor Weerasekara. Through this video, we will have the opportunity to witness the milestones, achievements, and memorable moments of his life.
In the realm of academia, there are individuals who leave an indelible mark on the institutions they serve. Today, we gather to celebrate the remarkable career of Professor Weerasekara, who has dedicated decades to the pursuit of knowledge and excellence. Born on the 23rd of September 1958, Weerasekara is the youngest of 3 boys. His journey began with academic brilliance, achieving the best advanced level results at Royal College in the year 1976. Known for his studious nature, he still cherishes some of his school books, a testament to his enduring passion for learning. His academic prowess extended beyond the classroom as he took on the role of president at the Photographic Society, showcasing that he possessed a keen eye for both equations and aesthetics. His exceptional academic journey continued as he joined the Katubati campus of the University of Sri Lanka in 1977, eventually graduating from the University of Moratuwa in 1982. In 1983, he joined the Department of Civil Engineering of the University of Moratuwa as a probationary assistant lecturer. In 1985, he embarked on a journey to Calgary for his PhD at the University of Calgary. His dedication and commitment were evident in the near-perfect GPA he achieved during his time there. He obtained his doctorate in 1991 and returned to the University of Moratuwa in the same year as a senior lecturer, grade 2. He was promoted professor on merit in 2009 and senior professor in 2017. He obtained charter status from the Institution of Engineers Sri Lanka in 2006. March 1997 marked a significant chapter in his life when he married Weerasekara. The couple welcomed their daughter, Ravindri, into the world in 2002. Although he lost his beloved wife in 2012, undeterred by the heartbreak, he embraced the role of a dedicated single parent, raising a then 10-year-old Ravindri with unwavering love and strength. Professor Weerasekara specialized in education technology, structures, and civil engineering, and he has taught courses at both undergraduate and postgraduate levels, ranging from structural mechanics and analysis to design of pre-stressed concrete structures. He became a renowned figure among students, known for his impeccable handwriting and clarity when delivering lectures. His commitment to education went beyond the classroom, as he proudly owns a vast collection of handwritten lecture notes. As a leading figure in the building and structural engineering group of the department, Professor Weerasekara contributed immensely to the improvement of structural analysis and design modules of the undergraduate program. He played a pioneering role in the commencement of the postgraduate course in Structural Engineering Design and served as its first coordinator. He taught a number of modules on the course and even those on the Highway Engineering postgraduate program. Professor Weerasekara was also a resource person and the organizer of several short courses organized by the Department of Civil Engineering under the auspices of Unique Consultancy Services of the Faculty of Engineering. The topics covered were bridge engineering, water retaining structures, transmission line structures, and finite element analysis. Some of these courses were repeated due to the heavy demand in the industry and academia with the support of ASCOM's AIT, of which Society of Structural Engineers acted as a satellite center. He has supervised numerous final year undergraduate research projects and postgraduate research students, where his research interests have been in the areas of structural engineering and encompasses analysis, design, and material technology. He is also the co-author of over 60 research papers. His dedication to education extended across borders as he served as a visiting professor at the Department of Civil Engineering at the University of Calgary in 2001 and at the Department of Civil and Resource Engineering at the University of Auckland, New Zealand and the University of Canterbury, Christchurch, New Zealand in 2002. Professor Weerasekara also served as the first Director, Quality Assurance at Faculty of Engineering for 3 years. He introduced a process of documentation that enhanced the quality of teaching and assessment within the faculty. Having held several posts in the Society of Structural Engineers for well-nigh 25 years, including that of Honorary Secretary for 7 years, Professor Weerasekara was elected to the coveted position of President for 4 consecutive years from 2012 to 2015. In the year 2015, he had the privilege of being chair of the Silver Jubilee International Conference in Structural Engineering in Colombo on the theme Towards Excellence in Structural Engineering, a conference well attended by world-reputed professionals in structural engineering. In recognition of his overall career, achievements, and his dedicated service to the structural engineering community, he was conferred an honorary fellowship in 2017 by Society of Structural Engineers, Sri Lanka. He has also been a practicing structural and civil engineer for several projects in Sri Lanka. Today, as we bid farewell to this illustrious career, let us reflect on the impact Professor Weerasekara has had on countless lives, shaping the minds of future engineers. We express our heartfelt gratitude to his unwavering commitment and wish him the very best for the new chapter of his life.
So, as we continue to honor Professor Weerasekara, it is with immense pleasure that we present him with a souvenir book containing heartfelt wishes from his teachers, family, colleagues, industry personnel and grateful students. This book serves as a token of our appreciation and gratitude for his invaluable contributions and a heartfelt note on the positive impact that he had in shaping our lives. So let me invite Professor Weerasekara back on stage, and to present the souvenir I cordially invite Professor Ajit D. Alvis, Dean, Faculty of Graduate Studies. Thank you, sir. Nearing to the conclusion, I extend my sincere gratitude to each and every one of you for joining us today, physically as well as through Zoom, to celebrate the illustrious career of Professor Weerasekara. Your presence here is a testament to the profound impact that he had on our lives. First and foremost, I would like to express our deep appreciation to Professor Weerasekara for sharing your invaluable experiences with us as you bid farewell to this institution. I would also like to extend a special word of thanks to Dean, Faculty of Graduate Studies, Professor Ajit Alvis, for gracing this occasion. Next, my sincere thanks goes to Professor Chinta Jayasinghe, Head, Department of Civil Engineering, and all the emeritus professors and senior staff members of the department who wholeheartedly rendered their support to make this event a success. And special thanks goes to Ms. Ravindra Weerasekara, who provided us with all the important information and nitty-gritty details as well of Sir, which went to the nice video and the souvenir. Dear invited guests from the academia and the industry, your physical presence here today elevated this occasion to another level. Thank you very much for your time and effort to be here amidst your busy schedules. My deep appreciation for all the academic and non-academic staff members of the Civil Engineering Department for their unwavering support to make this event a reality. I would also like to thank Faculty of Graduate Studies for lending us the Zoom room and providing us with all the facilities today. Special thank goes to Mr. Sanjay and the team from the audio visual unit, and Mr. Nadisha from the CITES for your invaluable contribution to broadcast this event globally. I would also like to extend a special word of thanks to Chamira Randil, who was the main person behind all these wonderful graphic designs. And a special thank goes to the video and graphic design team, Ms. Dulanji Thoradeniya and Mr. Nipun Vimalasuriya. Thank you for your amazing job. And a very special thank goes to the past undergraduate and postgraduate students of Professor Weerasekara, who were for their generous contributions to make this felicitation event a success. Last but not least, I would also like to thank all the people who are joining from all around the globe via Zoom, friends, family, past students, current students, colleagues, industry partners, and well-wishers. We really appreciate your presence, and it proves the positive impact Professor Weerasekara had on society at large. So let us continue to uphold his legacy and carry forward his teaching and values in our pursuit of knowledge and excellence. Thank you and have a wonderful day. We kindly invite you to have the refreshments. Thank you.